Hello everyone and welcome. In this video we are going to discuss how to design video streaming platforms like YouTube and Netflix. Okay, YouTube and Netflix are very well-known services and don't need any introduction. So we'll directly dive into the functional requirements of these services. Okay, so these services allows users to upload video, stream video and search videos. Okay, these are the primary things that these video streaming services allows users to do. Now users could be anything. They could be the end users or the consumers of the content. They could be uploaders of the content. In case of Netflix, the Netflix itself is the uploader of content, right? But anyways, it will allow these three services as well. Now services like YouTube allows user to like or dislike video, add comments and view thumbnails. For this discussion, our primary goal would be discussing the above three services: upload video, stream video and search video. Okay? So these are pretty much the functional requirements of video streaming service. We'll now discuss the non-functional requirements. Okay, the service should be highly available. What is meant by highly available? The service should still be operational or functioning, working even in case of network failure or if the machine breaks down. Okay? Service should always be available. Then there comes reliability. Whatever content has been uploaded by the user, that content should not be lost. Okay, it should remain intact. Even if it is not lost, it should be present in the state in which the user had uploaded the content. It should not get corrupted. That is meant by reliability. Then there is low latency. Whenever user tries to search for video or stream video, watch video, the experience should be smooth with minimal latency or no latency at all. Okay, so that is meant by low latency. And of course, since we are talking about a scale of millions of people watching videos every day and hundred thousands of videos being uploaded every day, the system should be able to handle this kind of scale. Okay, so as the requirement grows, the system should be able to grow with it smoothly. Okay, now let's see what all things will we need to store while designing this kind of service. So very first thing is that we'll need to store details about user. What kind of details? We'll need to store username, user ID, then email, password. That is pretty much it. That is all you need about user. Okay? Then you will need to store the details of channel. What details? You will need to store channel ID, the description of channel, then channel name, number of subscribers, and you will need to store the user ID. Why do you need to store user ID? You need to know which user does this channel belong to. So you need to store user ID. What metadata do you need to store related to videos? First of all, you will need to store the video ID, video title. Then you will need to store channel ID to know which channel does this video belong to. Post that, you will need to store the video description, the number of likes or dislikes on video, views count, how many views that video has got, the privacy level, whether the video is public or private, like that, the privacy level. Apart from that, you will need to store URL, location and blob storage. Now here you need to understand that this is metadata related to the video. Okay? This is not the actual video. So actual video is going to be present in some object storage like S3. Okay, in the video metadata you will need to store the link location to that to the object storage where the actual video is present. So this is that. Then you will need to store comments. So in comments you will need to store ID, comment ID, user ID to know which user has posted that comment, then the actual message or the actual text of the comment. Then you will need to store the number of likes on the comment, and you will also need to store the video ID to associate which video does this comment belong to. Okay? So this is pretty much the user and the metadata that you will need to store. Okay, Now let's see what database should be used for this. Now if you see, this is pretty structured data. It has a straightforward format. Okay, the format does not keep changing, so this is structured data. One thing to observe is that many fields in the table are foreign keys from another table. Let's see. You see user ID in this particular table. You see user ID in this particular table. This user ID is foreign key from user table. Okay. Then you see channel ID in this table. It is foreign key from this particular channel table. Then you see video ID in comments table. Video ID is foreign key from video table. So you see many tables have foreign keys here. What does this mean? It means that getting data from these tables is going to be a complex query. Okay? And it will involve join operations. So these are the three observations from the data that we are storing. What? It is structured data. Many fields in a table are foreign keys from other tables, and fetching data from this table will involve complex queries and join operations. Okay? Now given these characteristics, SQL is the best suited database because it seamlessly handles complex queries, relations, joins between tables, and it follows strict schema also. So for our use case, SQL is the best suited database. Okay, now let's see how will the high level design of our video streaming service look like. So all the client services or the client request would be first hitting the web server. This web server, the request from web server will go through API gateway and will hit API server. Okay, different API servers. So this represent cluster of different APIs. Now why do we have a separate web server and API server? It is because we want to separate the client servicing logic with our core application logic. Here is from where our core application logic starts, and we want to separate our core application logic from the client servicing logic. Okay, that is why we have two different web servers and API servers. Now what is the advantage of separating these two services? The advantage is that we can use different tech stack for web server and API server, and we can scale them independently according to the needs. Okay, that is why we have different web server and API server. Now API server will be hosting these APIs: upload video, search video, watch video or stream video, like or dislike video, and commenting upon the video. So these are the APIs API server would be hosting. Now API server is connected to the SQL data store. SQL data store is used for storing the user data and the metadata related to the video. Okay, then post that, API server is connected to different microservices that we'll be using, like upload video, streaming video, searching video. We will have separate microservices for them. Then we had already discussed that the original video is going to be stored in object storage or blob storage like S3. So all our videos are going to be stored in a blob storage. Okay? Once the videos are stored in the blob storage after they have been uploaded, we'll distribute these videos on a global network of CDNs. Why do we distribute them on CDNs? We want the videos to be geographically closer to the user. Okay, so we don't want user request to hit every time to the original source of the video. We want our video to be distributed onto the CDN networks. CDN servers are present geographically close to the user's location, so it helps serving the video quickly, and it reduces the latency. Now what criteria should be used for basically selecting video to be put on CDN server? We'll use criteria like access frequency of the video, how popular the video is, and geographic demand for the video. So certain videos could be uh, certain videos will have more demand in a particular area. Like if you take example of some video whose language is Marathi, so it would be more watched in Maharashtra region, whereas Telugu videos would be more watched in Telangana and Andhra region. It is just a small example. It is actually a globally distributed network. So that is how we'll decide which video to put on which CDN, which video should be put on CDN server. Okay, so that is pretty much the high level design of the system. Now let's deep dive and see how will we design different microservices that we had discussed. The very first microservice was uploading video. Okay, so whenever we upload video, it will first go to the file chunking service. What is file chunking service do? So file chunking service converts video into small segments of fixed size, and each segment with each chunk generated, it will also generate metadata such as the video ID to which the chunk belongs to and the chunk number. Okay, these chunks are stored in some temporary storage while the post the chunks are generated, and once all the chunks are generated, all these chunks are combined into a single file. Now you may ask question, if we had to combine it into a single file, then why is chunking needed? To answer your questions, these are the reasons. So let's say while uploading a single video, if the connection breaks, in that case, if we have a single file being uploaded, let's say you have a video of 1 hour, and after uploading for 45 minutes the network connection broke down. Okay, so when the network connection gets back to its previous state, when you have healthy network connection, you will have to upload the complete video again. So in that is why if we have chunks, if the connection breaks, only the current chunk needs to be retried, and all the chunks after the current chunks would be retried. There is no need to upload the complete file again. And when there are multiple chunks, we can upload these chunks parallelly, so it will speed up the uploading process. That is why we need to have chunks. Okay, now second question is, why do we need to combine? We have already chunked the video, why do we need to combine it again? It is because ahead of chunking service, this video file is going to be given to transcoding service. Okay, so the transcoding service needs a complete video. Why is that so? It needs it because it is a global content context aware process. Okay, videos are not just stream of images, they have specific encoding format which includes headers, keyframes and predicted frames. Now if you chunk the video, it might happen that that particular chunk will not contain the header only, it will only contain the keyframes and predicted frames, it will not contain header. Without header, the transcoding service cannot work properly. So whenever you are encoding a particular frame, it will need the previous frame's reference also, and it will need the next frame's reference also. That is why it is called a global context aware process. So transcoding service needs a complete video. That is why we'll need to combine these chunks again. Okay. Now what is transcoding service? We have transcoding service. Let's discuss what does this transcoding service do. So a transcoding service converts video into multiple formats or multiple resolutions. So let's say you have uploaded video in 1080p, it will convert it into 720p, 480p like this. Now why does it need to convert it into different resolutions? It is because it will need to provide video based on the network bandwidth requirements. If you don't have enough bandwidth for 1080p, it will have to, the video will have to be streamed in 720p. So transcoding service converts a video into multiple resolutions. Then transcoding video also chunks the file again and packages them into the protocols like HLS, MPEG dash. So streaming on different devices like TV or like on Android device or an iOS device, for there are different protocols for streaming a video on different devices. So it needs to package the chunks in different formats like HLS formats for iOS devices, MPEG- format for Android devices. Now you could ask questions why we have chunked initially, then we combined it again, and why are we chunking it once again after combining. It is because similar to the streaming uploading process, like uploading chunks instead of a full video is a better option, because it helps in case of network connection breakage and varying bandwidth requirements. Similarly, while you are streaming video, having file in chunks is better than having file a complete file. Okay. You will understand why chunking is required again better when we discuss the streaming service. Okay. The next thing that a transcoding service does is it generates manifest file. Now what does manifest file contain? It contains the available resolution, in what all resolutions is a particular video available in. It contains URL to the chunks, it contains duration of each segment, and it contains codec info, which is used for device compatibility as discussed. What all resolutions and formats is a particular chunk available in, like HLS is used for iOS and MPEG- is used for Android. So a manifest file will contain all this information related to a video. Okay. Apart from this, transcoding service also does thumbnail generations. So since it is chunking and processing the video, it will capture images after every x seconds. Okay, it will capture these images and it will post the video upload is done. It will suggest what thumbnails do you want. So it also does thumbnail generation. Uh, Once all these processes are done, it uploads files into permanent storage. So that is what a transcoding service does. The next service that we have is video streaming service. Okay, so whenever a client requests a particular video, the request goes to the closest CDN server. Okay, so it will go to the closest CDN server. Now if the CDN server has got the data and metadata related to that particular video, it will directly return the request, the response to the client. But if it is not present onto the CDN server, it will fetch the data from the source, the permanent S3 storage, and then it will return to the client. Now while getting the response from the CDN server, the very first thing that the client is going to get is the manifest file. It will first get manifest file and a few chunks in lower quality. Now we know that the manifest file contains all the resolutions in which the video is available and on all the formats in which the video is available. Okay, so the client will initially pick the video or the chunks with lowest quality or medium quality. Okay, and it will start streaming them. So its first priority is to start streaming. That is why you must have observed that whenever you start a video, it starts streaming in lower quality for first few seconds or minutes. Okay, post that, on the client side will have a library that will continuously keep checking the bandwidth and the buffer size. Okay, now if it realizes that the bandwidth has improved, network bandwidth has improved, it will fetch further chunks in higher quality. If it sees that the network bandwidth has decreased, or it is now the network is on a lower bandwidth now, it will download the further chunks in lower resolution. Okay, so it basically prioritizes playing video continuously over playing video in very high quality. So that is how it tries to avoid buffering. Okay, now this switching resolution based on the bandwidth is called as adaptive bitrate streaming. This whole process of switching video quality based on the network bandwidth is called as adaptive bitrate stream. So this is how video streaming service would work. Okay. The last service is the video search service. Okay. Now once the data uploading and transcoding is done completely, it is put onto the CDNs, right? So that means it is ready for users to be watched now. Now how would users watch the video? It will either be suggested in their feed, or it will either be searched by the user. Okay. So once the video transcoding and uploading is done, there would be a message queue which will receive a notification that video uploading is completed. Now we'll have a service called as data extraction service, which will pick this message from the message queue. Okay. What will data extraction service do? It will extract data like title of the video, channel name, video description. It will do the transcript processing. The video will have transcript which it will process. Why does it do the transcription processing? It needs to understand what kind of content is present on the video, in the video. Okay. After that, it may also, like services like Netflix or Amazon Prime, may also want to know the cast and crew of the video that is being, or the movie that is being uploaded. So it will try to extract this kind of data also from the video. Okay. So this is what the data extraction service would do. Once all this data is extracted, it is put onto the Elasticsearch cluster. Now why are we using Elasticsearch cluster particularly? Consider two cases. User is trying to search for a movie named Pirates of the Caribbean. Now while trying to search for it, it is highly probable that it would the user would end up doing spelling mistake. That is case one. Another case is user might not type the movie name directly. It will he will instead type Johnny Depp movie. Okay? So in both these cases, we want to return some results which are relevant to the query given by user. It could be spelling mistake, or it could be a very different title, Johnny Depp movie, like that. So it means that we want to have fuzzy searching logic. Okay, a user will not give exact query, but we still want to return the results that are somewhere near to relevance of the query. So it means that we need fuzzy searching logic, and Elasticsearch has this feature inbuilt. That is why we are using Elasticsearch cluster. Okay. Now whatever results are returned by Elasticsearch cluster, it is given to the ranking service or ranking engine. The ranking engine will rank the results returned by Elasticsearch. For that, it can use various criteria like text relevance, for which it can use TF-IDF, or it can also use the engagement scores of the videos returned by the Elasticsearch result. What will engagement score contain? It can use parameters like number of views, number of comments, number of likes on that particular video. So based on these criteria, the ranking engine would rank the results of the user is trying to search for. Okay. Now this is what search service would look like. Okay. Then while discussing the data storage, user and metadata storage, we had discussed that we'll be using MySQL or relational database for our storage requirements. But the problem with relational storage or MySQL is that it is not very easily horizontally scalable. So how did YouTube solve this problem? To solve this problem, YouTube developed Vitess. What is Vitess? It is an open source database clustering system, and it is designed to scale the relational or MySQL database. It has two primary components. First is the VT gate, and other is the VT table. So VT gate is a smart proxy or router service. So it will divide the Vitess would divide MySQL database into multiple shards. Okay. Now, whenever client tries gives a particular query, it will first go to VT table. VT table is a proxy service. It is a smart proxy service. It knows which shard will the data live on. It knows how to route and merge queries. So let's say the query result is coming from cross shards or multiple shards. So we have a query and its result is going to come from this shard also and this shard also. So this VT table is clever enough. It knows how to combine the results from multiple shards. Okay. It knows how to combine or merge queries also. It knows how to handle multiple shards transaction also, and it knows which shard will the data live on. So it is basically a smart proxy service. Other thing is VT table. So with a separate shard or with a separate MySQL instance, we have a separate VT table running. Okay. What does VT table do? It will handle the backups of each shard. Then it will handle the schema changes. If the schema changes on the shard, it will manage those schema changes, and it will also control the replication of each shard. So this using this Vitess, it is easy to scale the MySQL database horizontally. Okay. For video availability, so we have stored videos on a permanent storage, right? S3. So S3 is also easily horizontally scalable, and it is quite available service. So it ensures availability. So that is how we ensure storage, persistent storage, availability, and reliability of our service. I hope you would have understood this. Thank you.